Hello friends, myself R.D. Mahajan, Assistant Professor, MIT Aurangabad, presenting my video on the topic Laplace Transform of Unit Step and Displaced Unit Step Function, part third part. Earlier I have presented two parts on it. Let us revise the formulas. Laplace of unit step function u of t is equals to 1 by s, standard result. Second, Laplace of displaced unit step function u of t minus a is equals to e raised to minus as divided by s. Third result, Laplace of f of t, any continuous function f of t, multiplied by unit step function u of t, it is equals to f bar of s. F bar of s means the Laplace of this function f of t. Fourth result, Laplace of f of t minus a into u of t minus a. Displaced function, continuous function f of t minus a multiplied by displaced unit step function u of t minus a is equals to e raised to minus as. What is power here? It is a. For e raised to minus as into f bar of s. F bar of s means the Laplace of f of t. Okay. Therefore, these are the four standard results which we have to apply while solving the problems on it. Therefore, let us see some simple problems based on this all standard results. The first one, find Laplace of sin t into u of t minus pi. Therefore, to find this, we have to convert this sin t in terms of t minus pi. Therefore, we try to rewrite this as t minus pi plus pi. Adjustment. Subtract pi, add pi, so that original value remains the same. And it is equals to apply standard result from trigonometry. We know that sin pi plus theta is minus sin theta, and therefore it is minus sin theta is here t minus pi. Okay. And therefore Laplace transform of sin t into u of t minus pi is nothing but Laplace transform of sin t, we can replace by minus sin of t minus pi into this u of t minus pi. U or h, whatever. In some books you will find u, in some books you will find h, one and the same. And therefore it is equals to minus sign I can take outside. It is Laplace transform of sin of t minus pi into u of t minus pi. Therefore, we have converted this in this standard form. Laplace of f of t minus a into u of t minus a is equals to e raised to minus as into f bar of s, and therefore it is equals to, what is a here? It is pi. Therefore, e raised to minus as means e raised to minus pi s into f bar of s. F bar of s means Laplace transform of function f of t. That function f of t is here sin t. And therefore, it is equals to minus e raised to minus pi s, and Laplace of sin t is 1 upon s square plus 1, and therefore this is the Laplace transform of this function, or the required answer. Important is here, we have to take the help of that note, whatever I have discussed in earlier parts. F of t convert in the form of t minus e. Therefore, subtract pi, add pi, so that no change, and sin pi plus theta is minus sin theta. Therefore, minus sin t pi minus pi. and therefore Laplace of this means the Laplace of this new term, and then applying this fourth result, we get the required Laplace. Example 2, find Laplace transform of t e raised to minus 3t into u of t minus 1. Here it is f of t into u of t minus a, for which we don't have any standard result. Therefore, what we have to do? We have to convert this f of t in terms of t minus a. Therefore, let consider that t into e raised to minus 3t and rewrite in the form of t minus 1 by readjusting the term. I will subtract 1, add 1, so that no change. And in this term also e raised to minus 3 times again t minus 1 plus 1. Okay, and therefore it is equals to, we split this as e raised to minus 3 times t minus 1 into e raised to minus 3. Therefore that e raised to minus 3 I will write as separate term into, here it is t minus 1 plus 1 and multiplied by e raised to minus 3 times t minus 1. Okay, and therefore Laplace transform of this term t e raised to minus 3t into u of t minus 1, t e raised to minus 3t we replace by this new term. Therefore, it is the Laplace transform of e raised to minus 3 t minus 1 plus 1 e raised to minus 3 times t minus 1 and multiplied by u of t minus 1, and therefore it is equals to, this constant with respect to t, therefore we take it outside, it is e raised to minus 3 Laplace transform of, yes, what are the remaining terms? T minus 1 into this, we get t minus 1 e raised to minus 3 times t minus 1 first term, and plus 1 into this, we get e raised to minus 3 times t minus 1, and this complete multiplied by u of t minus 1. Therefore, it is f of t minus a into u of t minus a, f of t minus a into u of t minus a. Therefore, applying that, it is, means applying this fourth result, we get e raised to minus 3, e raised to minus as. What is a here? A is 1, and therefore it is e raised to minus 1 time s means e raised to minus s into f bar of s. F bar of s means Laplace transform of f of t. What is f of t here? If we remove that 1, it is t e raised to minus 3t first term and plus e raised to minus 3t. That is f of t, whose Laplace we require to obtain as f bar of s, and therefore it is equals to e raised to minus 3 e raised to minus s. Here it is some function f of t multiplied by e raised to minus 80 term, first shifting theorem, and therefore it is 1 upon, replace s by s plus 3 in the Laplace of f t. The Laplace of t is s square. Okay, and in that Laplace we have to replace s by s plus 3, and therefore here it is therefore this is the Laplace of the first term t e raised to minus 3t by first shifting theorem. I have performed the step directly. And then Laplace of this, Laplace of e raised to minus at is 1 upon s plus a is here 3. And therefore this is the required Laplace transform of this function. Okay. Therefore, if you want, you can combine this. We get e raised to minus in bracket 3 plus s, or we can keep this as it is. Therefore, once again I will repeat the steps. The first step, try to convert the function in the form of t minus a. Therefore, this t I will rewrite as t minus 1 plus 1, so that value does not change, only form we are changing, into e raised to minus 3t. In that also t is replaced by t minus 1 plus 1. Then taking e raised to minus 3 common, we get this one. Laplace of this means Laplace of this new term, and then applying this fourth standard result, we get the required. Another type of example that can be asked on this topic of Laplace transform, unit step and displaced unit step function. The question is, express into Heaviside and hence find the Laplace transform, and hence find Laplace transform of it. Function is f of t is equals to t plus 1 for the condition 0 less than or equals to t less than or equals to 2, and the second value is 3 for t greater than 2. Therefore, in this type of example, there are two subbits. First, express this function into Heaviside form, and then after getting that Heaviside, find its Laplace transform. Therefore, first of all, we try to convert this function in that Heaviside form. Here we take the help of the case number 4, whatever I have discussed in second part of the video for this topic. Whenever we require to find a portion of the graph between point A and B, therefore we write, we take the help of that condition. For 0 less than or equals to t less than or equals to 2, this f of t we can write down as per that condition, it is f of t. Here that f of t is t plus 1 into u of t minus a, the value of a is here 0, minus u of t minus b, the value of b is 2. Okay, and for this t greater than 2, f of t we can write down as that function f of t into u of t minus a is here 2, and then we take a combination of this Therefore, for condition t greater than or equals to 0, your function f of t has sum of these two. And therefore, first part is t plus 1. This one is u of t minus u of t minus 2 and plus 3 times u of t minus 2. And then there are two terms of u of t minus 2, combine it, and only one term of u of t. Therefore, we get t plus 1 into u of t and here it is 3 minus t plus 1 into u of t minus 2, and therefore we get this is equals to t plus 1 u of t, 3 minus 1 we get 2 minus t, 2 minus t, and we have here t minus 2. Therefore, to have that t minus 2, I will take minus sign common. Therefore, when we take minus sign common, terms becomes t minus 2. Therefore, original term minus t and plus 2 into u of t minus 2. We call this as equation 1. This is the conversion into Heaviside. Is the required Heaviside form, and after getting this, we have to perform the second part, try to get its Laplace transform. Therefore, finding Laplace on both sides for 1. This is your f of t. Taking Laplace transform of equation 1, and therefore Laplace of left hand side and Laplace of right hand side. Right hand side term t plus 1 u of t minus t minus 2 and u of t minus 2, and then taking individual Laplace, therefore it is equals to Laplace of the first term, Laplace of t plus 1 into u of t, and minus Laplace transform of t minus 2 into u of t minus 2. The first term is in the form of Laplace of f of t into u of t. Your f of t is t plus 1, and therefore applying this third result, it is equals to f bar of s. F bar of s means the Laplace of f of t, and therefore its Laplace is Laplace transform of f of t. F of t is here t plus 1. Second term is in the form of f of t minus a into u of t minus a. Its Laplace is e raised to minus as. A is here 2. Therefore, e raised to minus 2s into f bar of s. F bar of s means Laplace transform of f of t. That f of t is here t. Okay, and therefore it is equals to finding Laplace of each term. Laplace of t is 1 by s square, standard result, Laplace of 1 is 1 by s minus e raised to minus 2s, and Laplace of t again 1 by s square is the required answer of Laplace transform of that Heaviside function. Okay. One more example, example number 4. Again, express into Heaviside unit step function and hence find Laplace transform, and hence find its Laplace transform. The function f of t is two values. First one is sin t. For the condition 0 less than t less than pi, and second value is cos t for t greater than or equals to pi. Therefore, we have to convert this function into Heaviside form. First one is in the form of in between a and b, point a and b. Therefore, use that. Point number 4, how to convert, how to find a portion of the graph between point a and b. Therefore, for using that concept, for 0 less than t less than pi, this f of t we can write down as here it is sin t multiplied by u of t minus a is here 0, minus u of t minus b is here pi. Okay, and second, for this condition t greater than or equals to pi, f of t is equals to cos t multiplied by u of t minus pi, and then take a combination of these two, combine these two, and we write down for the condition for t greater than or equals to 0, your f of t is equals to sum of these two. Therefore, first one is sin t u of t minus sin t u of t minus pi, and plus cos of t u of t minus pi. Okay, and therefore only one term of u of t we write as it is sin t u of t, and there are two terms of u of t minus pi. Taking u of t minus pi common, we get here cos t. I will write down positive term first, minus sin of t multiplied by u of t minus pi. Okay, and therefore it is equals to sin t ut is in this form. Therefore we keep this as it is. We have to rewrite this f of t in the form of t minus a, so that we can use this fourth result. Therefore, cos t we can write down as readjustment, rearranged term, t minus pi, add pi so that no change, minus sine of again t minus pi plus pi, and it is multiplied by u of t minus pi. Okay, and this is equals to sin t ut as it is, cos pi plus theta is minus cos theta, and therefore theta is here t minus pi, standard trigonometric result, and sine of pi plus theta is minus sine theta, that minus and this minus, it become plus sine of theta, theta is here t minus pi, into u of t minus pi. We call this as equation 1. Therefore, I have completed the first part. Whatever the given function, I have converted in terms of Heaviside form, unit step as well as displaced unit step function. Okay, and second part, where to obtain its Laplace transform. Therefore, that part, this is your f of t. Next step is taking Laplace transform of equation 1. Therefore, Laplace of left hand side is equals to Laplace of right hand side. Therefore, Laplace of f of t, Laplace of right hand side term, I will take separate Laplace. Laplace of the first term, Laplace of sin t into u of t, plus Laplace transform of, I will write in the positive term first, it is sine of t minus pi minus cos of t minus pi into u of t minus pi. And then using result number third and fourth. For this we use the third result. Laplace of f of t ut is f bar of s, means Laplace of sin t, and Laplace of sin t is 1 upon s square plus 1, and Laplace of f of t minus a into u of t minus a, applying this result, it is plus e raised to minus as, a is here pi, therefore e raised to minus pi s into f bar of s. F bar of s means Laplace transform of that function f of t. Here it is sin t minus cos t. When how to get that f of t from this term? Neglect that a from this. Therefore, if you remove pi from these two terms, whatever the term we are getting, that is your f of t. And therefore, it is equals to first term as it is s square plus 1 plus e raised to minus pi s, and finding the Laplace of these two terms. Laplace of sin t 1 upon s square plus 1, and Laplace of cos t is s upon s square plus 1, and this is the required answer or the required Laplace transform. Therefore, with the help of this 4 example, I have explained how we can obtain the Laplace transform of unit step as well as displaced unit step function. I have discussed 2 types of problem. First one where we find directly Laplace of that function. it is given in that form, a displaced unit step form. We have to convert that function first into Heaviside, and after getting that Heaviside, we require to obtain the Laplace transform. Okay, therefore two different types. In my next video, fourth part, I will discuss the problem based on the same 2 points, but when the function is given in terms of figure. How to obtain the Laplace transform? For that, I will explain in fourth. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates. Thank you very much.